Question 6, part E, asks to find dA on dR, which you may otherwise see as A dash, which means the derivative of the A equation, which I have brought down from part D above, where A is equal to pi r squared plus 1 million on R. So basically we just need to derive this equation here. Now there's the key concept of differentiation, and to explain that I like to write it like this. If we have a variable x, now our variables in the A equation is r, but let's say we have a coefficient of xa times the variable x to the power of b. To derive this, you bring the power out the front, multiply it by the coefficient of x, or the letter in front of x, and then subtract 1 off the power. So that's the sort of key differentiation concept. The other concept that we need to understand here is that 1 on r is the same as r to the power of minus 1. Likewise, 1 on, these are just variables, doesn't really matter what the letter is, but 1 on x squared is the same as x to the power of minus 2. It's a way to express when we have a fraction with a variable on the bottom as it not being a fraction. So we just reverse the power, the sign of the power. Okay, and the reason that we do this will become clear, but it makes deriving easier. So actually I will leave that there. So first things first, I'm not going to derive A, I'm just going to rewrite A as pi r squared plus 1 million r to the minus 1. So I haven't derived, I've still got A, but instead of writing it as a fraction with the variable r on the bottom, it's now r to the power of minus 1. So now I can derive this dA on dr using this concept here. We have two terms, so we'll do them one by one. Pi r squared, we bring the power down the front, so 2 pi r, and then we subtract 1 off the power, so 2 minus 1. And then, now, interesting here, I'm not going to write plus. No, actually I will write plus. The minus 1 comes out the front, and that's times by 1 million r to the, and we minus 1 and we subtract 1 off the power. So let's go ahead and clean this up. It becomes 2 pi r, because 2 minus 1 is 1, and when it's just to the power of 1, we don't write it as 1. And then minus 1 times a million will be minus 1 million r to the power of minus 2, because minus 1 is 2. And we need to clean it up one step further, because we should always leave our answers with positive powers. So we're doing the reverse now of this. We're actually bringing r to the power of minus 2 underneath to be r squared, positive power squared. And there we have it. There is the derivative of A. It's called dA on dr. And in the next few questions, we will be showing why this equation is very important. But that is the answer to part E, question 6.